Okay, so this is Superlab 1, and this is going to be the second of our multicast MVPNs next generation style. So Superlab 1 has a very similar setup to the chapters, but the chapters are running RSVP, and Superlab 1, we're going to be running this MVPN over LDP. Now, currently our LDP is actually tunneled over RSVP, and that's not going to work because in order to build the point-to-multipoint LDP LSPs, we have to be running the LDP native. So first thing we have to do is put LDP on everywhere that we're running this, and that way we can enable LDP point-to-multipoint, and it will be able to set those LSPs up in a point-to-multipoint fashion. The second thing that we need to do is to look at where we're running our PIM. Now, in the previous chapters, we had PIM running as provider PIM on the backbone, and that was really nothing to do with the next generation multicast VPN. However, we must also be running PIM inside our next generation multicast VPNs as well. And the reason is, if you remember, if we have a customer here, we're going to be running IGMP on the customer side. As that goes into the PE, across here we're going to be running customer PIM, and then that will be going into a BGP signaled, rather than provider PIM, cloud, have another PE here, and then we need more customer PIM between the PE and the CE. And what that means is that for our VPNs, we need to have protocols PIM on all the interfaces inside our VPN, which in this case is the CE2 spoke, and that will effectively enable customer PIM between the PE and the CE. We also need to enable a rendezvous point address on this, even though we're going to be running SPT only. Inside our multicast, we're going to be running source only. So on an ordinary multicast setup, you could avoid the rendezvous point. However, we've been asked to establish it here. And it just helps in that conversion between customer PIM, which is going to be required in some form or another, and the BGP signaling. And we've been asked to do it. Okay, so the next point here is the configuration of the multicast VPN. So we're inside our routing instance, we're inside our VPN, and we've got these targets here. Now let's have a recap of the targets as well. Okay, so we know there's two ways to put on targets. You can put the target in a layer 3 VPN, and it will effectively move routes in and out of the BGP L3 VPN table, or you can have VRF export and VRF import and do that, manually with much more control, which is what we're running here. However, within multicast, we have the option to have a separate target just for the multicast. So the unicast will be one target, the multicast to be another, and this is where we configure it inside the MVPN. So root target, export target, which you only really see in these multicast VPNs. There's an extra word target here, so the structure is very slightly different. And then remember as well that we also have this RT-import, which really is acting like another target on the multicast. And that RT-import is still being used. And if you remember, that's what happens when you turn on the multicast signaling on the BGP. It adds that extra route import onto the unicast routes. So there we have it. This allows the multicast to be a different target to the unicast. Okay, so we've looked at where the PIM's running. We've turned on the PIM. Obviously, to do that, we've also had to add an IP address up onto our loopback, and then we have to make sure that that IP address doesn't become primary for the other functions. Otherwise, we would be in all sorts of trouble there. So, extra loopback. Here for the rendezvous point, we've configured the PIM and the rendezvous point, turned PIM on all the customer PIM interfaces. We've enabled LDP everywhere in its native form. We've turned on multicast for the LDP, and then we've configured our main command that holds it all together, which is our provider tunnel. And this is what adds that inclusive PMSI, 'I' onto the interface. So this is the beginning of our LDP point-to-multipoint multicast tunnel. Finally, down here, we have got a static statement here. This is very useful. This is effectively setting up a static PIM join by having an IGMP configured right on the customer interface, and that enables us to not require all sorts of traffic generators and IGMP hosts generating those PIM connections. So this is the last two pieces of this. Firstly, of course, we have to remember to turn on the BGP signaling on the route reflector. And then we have to remember that when we turn on the BGP signaling, it actually adds 2 extra communities to the unicast routes. Now, these communities are RT import and source AS, and they really are like an extra route target. They're hidden. When we look in the hidden policy here on the spoke side, we see it. It even calls it a target, in fact. Now, if you remember, on the spoke side, we're turning on the multicast, and consequently, we're getting these communities added to the unicast routes on the spoke side. But it's the hub side that's providing the unicast routes. So what we have to do, we have to take these values and we have to copy them into the unicast routes on the hub side. So here we've taken the value from the hidden policy, that is from the spoke side. We're then defining those 2 new communities, source AS and RT import. Remember, RT import is going to be like an extra route target, and we're then attaching those onto the export on the hub side so that the hub unicast routes get the same values. And then the unicast routes from the hub side, which is where all of the routes are being sourced, is going to be able to do the RPF checks and function correctly for the multicast.